today I am going to discuss about resistance. They are connected in series as well as they are connected in parallel. After that I will solve several questions which are related to resistance in series as well as resistance in parallel. Please listen carefully. Now I will start with my topic. Let's go. Okay, so here resistance in series. If we assume there are three resistors are there and they are connected in series connection. Series means what? If suppose I am a resistor, I have contain two ends. That two ends, one end which is connected to other resistor whose other end, and my opposite end which is connected to other resistor. Okay, so they are combined represent as series connection. तो आम ओडिया कही परिबा कोन पंक्ति संयोग. Here this is the resistor number 1 and that resistor number 1 whose one end connected to other end of the resistor and other end of the resistor, second resistor which is connected to another resistor. So this is called series connection, and that resistor they are connected to a battery or cell, so that it has some potential difference, that is V volt. That means that high terminal has plus and that can be denoted as a V volt, and lower terminal that can be represented as negative and it is denoted as a 0, so that there is a potential difference in between them is V volt. V minus 0 equal to V volt. That's why due to applying of cell to that given resistor, and they are represented as three resistors R1, R2 and R3. They are connected in series to that given cell, so that the cell has potential difference V volt. That means that one end has V volt and other end has 0 volt. So whenever we have used that cell, so that there is a current which is drawn toward the resistor, that is I amount of current which are going to that all resistors, that is I, that is also I. After that it moving toward the negative terminal of battery, so that current which moves in a complete path. Okay, clear? So here we write that let us consider three resistors which are connected in series of resistances R1, R2 and R3. Okay, that resistors are connected to a battery or cell. Which has potential difference V volt. Clear? Which has potential difference but V volt. So here in series connection, whenever the current flowing through that all resistors, then across each resistor current remains same because they are connected in series. In series connection, current remains same. Okay, in series connection, current I remains same, but there is a potential differences here across each resistor. There is a potential difference is here, and that potential difference becomes different in across each resistor. Okay, according to Ohm's law. According to Ohm's law, as we know that V equal to IR. Okay, V equal to IR. For first resistor, we can say that resistor has a resistance R1. That's why that resistor across that resistor whose resistance is R1 according to Ohm's law. But that current passed through each resistor remains same. So I remains same. Okay. Due to change of resistance, voltage also changes. So across each resistor, potential difference becomes change. According to Ohm's law, as we know that V1 equal to IR1, similarly V2 equal to IR2 and V3 equal to IR3. Okay. So if there is a change of resistance, due to change of resistance, potential difference also changes, because there are several number of resistors are there and they are different. That means whose resistances are different. That's why its potential difference are different when that resistors are connected in series. From above consideration, potential difference across each resistor are different when they are connected in series. Okay. When they are connected in series. If we assume that number of resistors whose resistance is same, then we can say that then we have assumed the potential difference remains constant. Otherwise, that is the possibility case. But if the resistor whose resistance are different, okay, and they are connected in series, that's why the potential difference across each resistor, that is the first resistor, across the first resistor the potential difference is V1. Across second resistor the potential difference is V2. This is the V2, and this is the third resistor whose potential difference is V3. Okay, but in case of series connection, current remains same while it moves from one resistor to other resistor while they connected in series connection. Clear? Please, this is the important thing. Note it. This one and this one. Clear? Okay. This is the important. मुझे ओडा को underline करचे ताको तमे note बोली की कोई लेखो. Okay. Please note it. Then I will erase that thing. Now we can assume as that three resistors converted into a single resistor that behaves as effective resistance. whose resistance is given as effective resistance. So RE, and that effective resistor which is connected to a battery. So there is a effective potential is there, that is V, and 0 is here. That means there is a potential difference is here. Therefore, as we know that effective potential difference equal to sum of potential difference across each resistors. Okay. Here we assume that 3 resistors converted into a effective resistor of resistance RE, and there is a potential difference across that resistance is given by VE, or V is given by V. Therefore, net effective potential across effective resistor which is equal to potential across each resistors. So that is V1 plus V2 plus V3. So that V1, we can say that the potential difference across resistor number 1. V2, we can say that potential difference across resistor number 2. And V3, we can say that potential difference across resistor number 3, and they are added. So according to Ohm's law, V equal to what? IR is here. So V effective equal to what? I into R effective. So I into R effective is here. So I into R effective equal to, here I into, because current remains in series connection, R can be represented as a R1 plus I into R2 plus I into R3 is 0. Now I into RE equal to, here in all this thing I remains constant, so I remains same, so they are taken in outside. So I into R1 plus R2 plus R3 is here. That means I cancel out. So net effective resistance equal to R1 plus R2 plus R3 is 0. Clear? Therefore, the net effective resistance when the resistors are connected in series whose resistances are R1, R2, R3, then we can say that net effective resistance equal to R1 plus R2 plus R3. Clear? Please note it. Now I am going to discuss about special case of resistance in series. Here number of resistors are whose resistances are remain same, R, and they are connected in series to that given cell of potential difference is V volts. Okay, V volts. That means that is V, that is 0. Clear? Here the number of resistors are whose resistances remains same, that is R. Here the n number of resistors, n number of resistors, n number of resistors whose resistances remain same, that is R, and they are connected in series. Then net effective potential, net effective resistance is given by what? R effective equal to, here n number of resistors, R plus R, okay, plus dot dot dot, okay, get the times n times, okay. Here R can become, here R remains same, that means capital R, that is R, here that is capital R. Here already I mentioned in capital R, so here capital R is here, okay. Re equal to R plus dot 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 n times. So if you common R, that means 1 plus dot dot dot, what? N times, that means what? N into R. So net effective resistance, while n number of resistors are connected in series, then its resistance become NR. Clear? This is the special case. Okay, in series connection. If number of resistors are connected in series, if n number of resistors are connected in series, whose resistance remains same, that is R, and they are connected to a battery, then effective resistance of n number of resistors are given by R equal to n into R. Here n equal to number of resistors, R equal to resistance. Please note it. Play. Now I am going to discuss about resistance in parallel connection. Resistance in parallel connection. Here 3 resistors, 1 resistor, this one is 2 resistor, this one is 3 resistor, third number resistors. First resistor, second resistor and third resistor, whose right points or right parts, they are connected at a particular points. This is the right parts are connected in particular point, and left part also connected to particular point. Right part connected to a particular point and left part also connected to a particular point. So they are behaves as a parallel connection. All these right parts are connected to particular point. All these left parts are connected to particular point to that given battery. This is the battery, okay, which has potential difference V volt. That becomes V volt. That means there is a potential difference between them is V volt. That means that becomes V volt and that becomes 0 volt. That means there is a difference between V volt and 0 volt is given by V volt. So that terminal which is connected to that point, so it has V volt, and that terminal has 0 volt. So always we know that current moves from higher potential to lower potential. Okay, if the potential remains balanced, then there is no current which is flowing through that given parts. Okay, here that resistors whose resistances are R1, R2, R3 is here. Okay, now current flowing through that parts due to cell, because cell provides energy so that there are number of charges which are flowing through that circuit. That means it generates a current, because the flooding of charge will generate a current. So oppositely, current moves from higher potential to lower potential in a given circuit. That means I, and at that junction, that I converted into three parts, that is I1, if you assume, that is I2, and that is I3. So in parallel connection, we can say that the current becomes what? Distributed. Current becomes distributed. Okay? But three ends of the resistors which are connected to potential V volt, and three ends of the resistors which are connected to 0 volt. That means across each resistor the potential difference remains same. That's why we can say that, okay, the potential difference across resistors remains same when they are connected in parallel, but current becomes distributed. That means currents remain different in parallel connection, but potential difference remains same in parallel connection. Okay, so देखो पहले एटी I1 जाउछ, I2 जाउछ, I3 जाउछ, एटी कोन आसी I1 आसिला, एटी I2 आसिला, एटी I3 आसिला, आसी कि एटी कोन हला I करेंट गला। तातो हमें कोन कले तीनटा पाथ जेतोले रिप्रेजेंट करे, तीनटा पाथ देखि करेंट गला, किंतु पूर्व केस रे कोन होतला गोटे सिंगल पाथ थिला जो देखि करेंट सेम थिला, सेटा कोइबा सीरीज कनेक्शन आ कोइबा पैरेलल कनेक्शन। हियर वी राइट दैट there are three resistors of resistances R1, R2 and R3. All are connected parallelly to that cell of potential difference is V volt. Clear? According to Ohm's law, what will happen? We know V equal to what? I into R. But in that case, in parallel connection, what? Current remains different. So here I can represent as a I1, that implies current remains different, so I1 equal to V by R1. So R1 also different and I1 also different. So current becomes distributed in all parts across each resistor. That means I1 equal to V by R1, because potential difference remains same across each part. Okay, so V equal to I1 into R1. Similarly, V equal to I2 into R2. That implies I2 equal to V by R2 is here. Similarly, V equal to I3 into R3. That implies I3 equal to V by R3 is here. Please note it. Because at that case, in parallel connection, potential difference across each resistor remains same. Okay, in parallel connection, potential difference across each resistor remains same, but current becomes different. Okay, so please note it, this is the very important point. In parallel connection, potential difference across each resistor remains same, but current becomes different. and they are distributed across each part. Okay, please note it. Now that circuit converted into a single circuit whose effective resistance is R. That circuit converted into a single circuit whose effective resistance is R, and it is applied by a potential difference is V volts. So it is RE, and there is a current which is flowing through that circuit is I. According to Ohm's law, what? V equal to IR. Clear? So here, now that circuit converted into a single circuit of resistance RE, and it is connected to potential difference V volts to a cell of potential difference V volts. Clear? According to Ohm's law, V equal to what? I into RE. Okay, that implies I equal to what? V by RE. Okay, therefore the current distributed across each part, therefore total current distributed across each terminal. So I equal to total current equal to sum of all current which are passes through each resistor. Sum of all current, that is I1 plus I2 plus I3. That is the sum of all current passes through each resistor having resistance R1, R2, R3 0. So I equal to I1 plus I2 plus I3 equal to total current. So as you know that I equal to what? V by R is here, V by RE. That implies that is equal to V by R1 plus V by R2 plus V by R3 is here. If you cancel all these things, then V equal to V by RE equal to what? V taken in common 1 by R1 plus 1 by R2 plus 1 by R3 is here. Clear? So VV cancel out. That's why 1 by R equal to RE equal to 1 by R1 plus 1 by R2 plus 1 by R3. Clear? Therefore, the net effective resistance when the number of resistors are connected in parallel, then it is given by 1 by RE equal to 1 by R1 plus 1 by R2 plus 1 by R3. When there are 3 resistors here, so that its effective resistance is given by 1 by RE equal to 1 by R1 plus 1 by R2 plus 1 by R3 is here. Now I am going to discuss about some special case which are related to parallel connection. Please note it. Now special case. Here the number of resistors. Here n number of resistors, that is whose resistances remain same, that is R. Second resistor whose resistance also R. Similarly, here there are number of resistors are there, and here n number of resistors is here. Okay, that is there are n number of resistors whose resistance are also R, and they are connected to that cell whose potential difference is V volts. V0, that is V volts. Okay, that is plus, that is minus. Here the n number of resistors, they are connected in parallel whose resistance are remain same. Okay, these are the n number of resistors. Clear? Here n number of resistors whose resistances remains same, that is R, and all are connected in parallel. They are connected to that cell of potential difference is V volts. Clear? Therefore, net effective resistance in parallel connection, that is 1 by Re equal to, here n number of resistors, that means 1 by R plus 1 by R plus dot n times. Clear? Clear? Now 1 by Re equal to, here 1 by R taken in common, 1 by 1 plus 1 plus dot n times. What? That means 1 by Re equal to what? N by R. That implies Re equal to what? Re by N. Clear? Sorry. Here Re equal to R by N. So this is the net effective resistance where n number of resistors are connected in parallel whose resistance remains same, and they are connected to a battery of potential difference V volts. Therefore, the net effective resistance is given by R by N. Okay. Already I have discussed in series connection, here n number of resistors whose resistance remains same, and they are connected in series to that given cell of potential difference is V volt. Then the net effective potential is given by Re equal to N into R. But in that parallel connection, Re equal to R by N. That means जो भी रेजिस्टेंस पैरेलल कनेक्शन में मिलिबो, जदि n नंबर ऑफ रेजिस्टर जदि कनेक्शन हुए से माने जदि पैरेलल कनेक्शन थांती ताहले से रेजिस्टेंस टा कोन हिजिबो, इफेक्टिव रेजिस्टेंस कोन हिजिबो, जो रेजिस्टेंस थिला तार n टाइम्स छोट हिजिबो. ओके, किंतु पैरेलल सीरीज कनेक्शन कोन होतला नेट इफेक्टिव रेजिस्टेंस कोन हिजिबो, n टाइम्स बढ़ जिवो. ओके, n टाइम्स मींस तीनटा थिले देखियो ताको धरि, चारटा थिले ताको धरि देखियो, पांचटा थिले पांचटा धरि. Into parallel connection कमी जाए. So this is the special case of resistance in parallel connection. Please note it. This is the very important questions which are related to board exam. Okay. Let's start with some problems which are related to resistance. They are connected in series as well as resistance. They are connected in parallel. Please listen carefully. And this is the very magical problems which are related to series as well as parallel connection. Here, here. Problem number 1. Okay. This is the connection. find the net effective resistance across AB. so कौन कही AB रो across रे ए जो तीनटा रेजिस्टेंस अच्छी से को कन्वर्ट करके सिंगल रेजिस्टर रे कन्वर्ट कर तार इफेक्टिव रेजिस्टेंस काढा बोली करिछि तो पिले मते कह तो एटा हम देखिबा हम एज्यूम करबा जे गोटे पोटेंशियल डिफरेंस गोटे लागिछि आमे धरि नबा मन रख मन भाव ये गोटे कोन लागिछि गोटे पोटेंशियल डिफरेंस लागिछि गोटे सेल लगाइछि बैटरी लगाइछि बोली भाव एक्रॉस ए को लगाइछि बी को लगाइछि तो ये गोटे सेल अछि जहाँ कि पोटेंशियल डिफरेंस होछि V volt that means higher potential represent as a V volt lower potential behaves as a 0 volt हमें जे पड़ भी नहीं परिबा एटा को लोअर नहीं कि सेपड़ हायर न लबी हो एपड़ हायर नहीं कि सेपड़ लोअर न लबी हो हमें कोन करिबा छी एक सर्किट को सॉल्व करिया पई हमें कोन करिबा छी गोटे सेल को हमें माइंड रे रिप्रेजेंट करिबा छी जोदरे कि से कोन दबो पोटेंशियल डिफरेंस जणेबो ओके सो एटी तुमको जणया पई एट कोन कले डॉटेड कले आकु इरेज कर दोछ ओके सो ले तुम माइंड रे कैप्चर करो जे अक्रॉस ए रे हायर पोटेंशियल लाइक छि अक्रॉस बी रे लोअर पोटेंशियल लाइक छि हमें जानि छे करंट ऑलवेज मूव्स फ्रॉम हायर पोटेंशियल टू लोअर पोटेंशियल दैट मींस अक्रॉस ए हैज हायर पोटेंशियल दैट इज V volt and B has lower potential it has 0 volt V volt clear so that's why it has V volt that means there is a current I current which is flowing toward the circuit now it becomes divided along this region okay that is I1 and this is I2 now it going in that way that is also I2 that is I2 and that is I1 now they are becomes related and they are adding with each other after that there is a current I is here that means the addition of I1 I2 gives what I current I which is divided into I1 and I2 after a junction it also adding so that they assumed as a I current so entering I current also leaving I current is here so हमको जति करंट जाइथिला सेति करंट बाहरिला तो हमर सर्किट ठीक अछि तार हम देखिले हम जानि जे जेतो हम सीरीज कनेक्शन पड़थिले कोन होतला जदि गुटे पाथ देखि जदि पाथ रे नंबर ऑफ रेजिस्टर लागंती सेमान जदि सीरीज कनेक्शन थांती ताहले जदि ता देकी करंट जाए ताहले कोन हबो करंट मींस सेम सो इट चिंता कर पिले I2 एट अछि 80 भी I2 अछि तार दुटा रेजिस्टर को कनेक्शन अछि सीरीज कनेक्शन अछि हमें जानछि सीरीज कनेक्शन रे नेट इफेक्टिव रेजिस्टेंस कहते हैं नेट इफेक्टिव रेजिस्टेंस इक्वल टू व्हाट R1 plus R2 okay so here we draw in a single circuit okay so that means that also represent as like that is single circuit now that becomes added okay in a single circuit that is A and that is B how to add it so here net effective resistance R prime equal to R double prime आकु नहीं जो R prime R नियो आकु नहीं जो R prime आकु नियो suppose आकु नियो R prime so R prime equal to what that is R1 that is आकु R नहीं जो R1 नहीं जो इट आसला कोन R2 plus R3 आकु नहीं जो R1 आकु नहीं जो R2 आकु नहीं जो R3 that means R effective पाइबा हले कोन करिबा R2 plus R3 करिबा that is the series connection अछंती तेनो एट लिखले कोन R2 केते 3 ohm plus 3 ohm that is केते आसला 6 ohm so net effective resistance in series connection that is R prime equal to what 6 ohm clear now here as you know that the current becomes divided so in which case current becomes distributed that is called parallel connection that means that resistor and that resistor they are connected in parallel That's why the net effective resistance across AB. So that means R effective across AB is given by, when you know that in parallel connection 1 by R effective equal to 1 by R1 plus 1 by R prime. Did you know that in parallel connection 1 by R effective equal to 1 by R1 plus 1 by R2? So 1 by R effective equal to what? That means 1 by R1 means what? That is what? This one is R1 means what? 2 ohm, that is 2 ohm is here. So 1 by 2 plus 1 by R effective is 1 by 6. So 1 by R effective equal to, so what will happen? Equal to, that means 2, 6, whose LCM is given by 6. So that means while we dividing 2, then we will get 3 plus 2, 3 plus 1 is here. 3 plus 1 is here. 6 divided by 6 is 1. So 1 is multiplied with that thing. So that implies what? That means 1 by R effective equal to 4 by 6. That implies R effective equal to what? 6 by 4. That means 3 by 2. So R effective equal to what? 1.5. So here R effective is what? That is 1.5. तो पहले मुझे पूर्वर कोई थी कौन पैरेलल कनेक्शन रो नेट इफेक्टिव रेजिस्टेंस कौन हबो दीटा रेजिस्टेंस थरो कौन जो कमी जो थरो 6 ohm थिला 2 ohm थिला एडे कौन हिला 1.5. So net effective resistance in parallel connection that becomes decreases. Okay, please note it, then I'll solve another problem. Second problem number 2. So this is the problem number 2. So here in problem 2, find net effective resistance across AB. Clear? एबे भी हम कौन करिबा एबे रो across रे net effective resistance calculate करिबा. तो हम प्रथम कौन करिबा सर्किट को ड्रा करिबा. तो पहिले चिंता करो हमें मन मन भाबी नबा जदी गुडे एट कोन अछि पोटेंशियल डिफरेंस हम जदी एज्यूम कर दबा धरे नबा माइंड रे मेकअप कर दबा ए गोटे बैटरी लागिछि. बैटरी जदी लागिछि ता तो बैटरी रो गोटे वोल्ट गोटे पार्ट कोन हिजबो हायर पोटेंशियल हिजबो अदर पार्ट कोन हिजबो लोअर पोटेंशियल. ता तो करंट मूव करे कोन हायर पोटेंशियल लोअर पोटेंशियल. ता तो करंट जदी मूव करंट जदी मूव कला कोड होला हायर पोटेंशियल. दिस इज हायर पोटेंशियल. करंट कोन गला इयाड गला ए करंट कोड जे कि इयाड गला ता तो एडी करंट जहा रहला एडी भी करंट ता रहला करंट डिवाइड होनी. ता तो जते बैंड थिले भी करंट जे तो आउडे पाथ मिलुनी ता तो ये कोन होछि डिवाइड होनी. तेनो एडी जा भी करंट होला that is I1, that is also I1 and that is also I2. So here at that junction what will happen? I1 is here and I2 is here. That's why they are added algebraically. That's why I is current is here. So हमको हमें कौन करथिले I current को एंटर करथिले I current को लीव पाइले. I current कौन हला लीव हला. तार हम जति के अमाउंट करंट जाइथिला सेति करंट कौन हला रिलीज हला. तार हम कौन करंट कौन हला कंजर्व रहला. चार्ज कौन हला कंजर्व रहला. ओके तो ए केस हमें देखिले तो फर्स्ट रीजन रे फर्स्ट केस रे कौन होचुंदी ए दिटा कौन होचुंदी सीरीज कनेक्शन रहचुंदी. सो हियर and that gives, suppose this one gives R1, that is gives R2 and that gives R3. Okay, so here R effective R prime equal to R1 plus R2 because they are connected in series connection. What? R1 and R2 they are connected in series because current remains same. We know current remains same in series connection but potential difference becomes different. Okay, so here R1 plus R2. R1 get the 3 plus 3 is 0, that is 6 ohm is here. So R prime equal to 6 ohm. So this is the circuit. So the net effective resistance here you can say that gives as R prime. That is called R effective equal to 6 ohm is here. Now that is R3 is here, that is 3 ohm is here. And that current which becomes distributed along two parts, that is I1 is here, that is I2 is here. So that is also I is here. Okay. So that is A and that is B. That means the net effective resistance across AB. A, B is given by what? That is R effective equal to क्या था सीखो देखो. Therefore R effective equal to that two currents are becomes divided. So in case of parallel connection, which as you know that the current becomes distributed or they are becomes different in different path. Okay, so that potential across that two path becomes same, so that they are assumed as a parallel connection. In parallel connection, we do know that one net effective potential, net effective resistance is given by 1 by Re equal to 1 by R1 plus 1 by R2. So 1 by Re effective equal to what? What? 1 by R prime plus 1 by R3. That means what? 1 by R prime means 1 by 6 plus 1 by 3. That means what? That 6 3 is a LCM of 6 3, that is 6. So 6 6 1, that is 3 6, that is 2. So that means what? That is 3 by 6 is 0. That is 1 by R effective equal to what? 3 by 6. That implies 1 by R effective equal to what? That is 1 by 2. That implies R effective equal to what? That is 2 ohm. What? 2 ohm. That is 2 ohm. So पिले मु कोन कहितली जेतोला हम पैरेलल कनेक्शन देखिबा, पैरेलल कनेक्शन रे दीटा रेजिस्टर रे जहां भी हमरो रेजिस्टेंस थिला से दीटा रेजिस्टेंस थरो तमरो नेट इफेक्टिव रेजिस्टेंस कोन को कम जीवो. इट इज कमिला देखो 6 थिला 8 3 थिला 8 कोन आसला 2 ओम आसला. Therefore in net parallel combination the net effective resistance should be less than that of two resistances when they are connected in parallel. But in series connection, the net effective resistance always more than that of number of resistors, whose resistances. Clear? Now I am going to discuss about next problem. Third problem, that is problem number 3. Here, if you assume problems like that, this is the problem. A and B is here. Okay? And all are having resistances. What? That is 2 ohm, 3 ohm, 3 ohm, 2 ohm. Clear? So find net effective resistance across AB. How to calculate net effective resistance across AB? So, assume there is a current which is flowing. That current it becomes divided I1, and that is also I1, that is also I2, that is also I2, because no path is here, only band structure is here, so that there is no current which becomes distributed. So here I1 and I1 is here, that means they are adding algebraically because they are connected in series connection. That's why we can represent in that direction, in that way, so we can solve easily that problems. Okay, so that is A and that is B, and that is 2 ohm, that is 3 ohm, that is 3 ohm, that is 2 ohm is here. So here given R prime equal to R1 plus R2 that means that is equal to R1, that is R2, that is R3, if you assume that is R4. Okay, clear? R1 plus R2. R1 means 2 plus 3, that is what? That is 5 ohm is here. Similarly, and second thing, R double prime equal to what? 3 ohm plus 2 ohm, that is R3 plus R4. They are also added algebraically because they are connected in series. So in series connection, as you know that R equal to R1 plus R2 plus dot 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 n times. So here R3 means 3 plus 2 is here, that is 5 ohm is here. Now they are connected in what? Parallel connection. So this is the parallel connection, that is the effective resistance across R1 R2, and that is also effective resistance across R3 R4. So that is R prime and that is R double prime is here. Therefore they are connected in parallel. So here they are connected in parallel. So net effective resistance, that means net effective resistance R effective equal to across AB equal to what? They are connected in parallel, that is I1 and that is I2. So they are connected in parallel. Therefore 1 by R effective equal to 1 by R prime plus 1 by R double prime. So 1 by R prime means what? 1 by 5 plus 1 by 5 is here. So if we calculate its LCM, then its LCM becomes 5. So 5 5 is 1. If we divide 5 in terms of 5, then it becomes 1. 1 plus 1 is 2. So 2 by 5 is here. That implies R effective equal to what? 5 by 2. So this one is 1 by R effective. Clear? 1 by R effective equal to 2 by 5. That implies R effective equal to 5 by 2. That is equal to 2.5 ohm. So that net effective resistance always less than that of two resistances when they are connected in parallel connection. Please note it. Then I will solve another problems quickly. Okay. पिले तुम किसी बुझा पड़थो तो मैं भी कौन करिबी डायरेक्टली सॉल्व करिबी आ तुमको मेंशन करिबी फटाफट में डायरेक्टली सॉल्व करिबी. ओके क्लियर. प्रॉब्लम नंबर 4. Same thing. That is also same problem, but quite different from the before one. Okay. So here the resistance becomes R, 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 R. How to solve this one? पहले हमें रूल पको करेंट हमें देखिए सब बड़े हमें एज्यूम करिया कोन गोटे सेल नबा सेल रो गोटे हायर पोटेंशियल अछि गोटे लोअर पोटेंशियल अछि. हायर पोटेंशियल हम कोन कले एज्यूम कले V वोल्ट एंड दैट इज आल्सो 0 वोल्ट. ओके. सो एबे हम कोन करिया V वोल्ट जो करंट जाउछि करंट कोन होछि डिवाइड होछि एटा होछि नली I1 एटनली I2 नली. क्लियर. अगेन कोन हला एडी कोन हला पिले I आल्सो डिवाइड हला पिले I कोन हला डिवाइड हला I डिवाइड एटनली ये कोन हला देखो एडी गला कोन सपोज आकु नै जो I3 करंट आकु नै जो I1 minus I3 करंट. क्लियर. I1 minus I3 करंट नै जो I1 रो कोन गला I3 गला बडगा के तरला I1 minus I3. तो एटी कोन हला पिले I1 minus I3 plus I2 ऐड हला एटी कोन हला I1 minus I3 plus I2 ऐड हला तार एटी कोन हला एका तसला देखो I1 minus I3 plus I2 एटा कोन हिला I1 minus I3 plus I2 करंट ए दे कला तार सामु कोन दगारो जदि करंट I करंट जाईची I करंट ही बाहरी बार अछि तार तो देखो I3 plus I1 minus I3 plus I2. That means I3 plus I1 minus I3 plus I2. तार तो कोन हला देखो I3 cancel हला I1 plus I2 I1 plus I2 that means I. So that is I current is 0. ओके हमरो आंसर ठीक होछ क्लियर सो आई करंट एंटर करथिल आई करंट रिलीज होला ता तो पहले देखो आउडे हम कोन देखिबा पोटेंशियल डिफरेंस देखिबा ता तो एटी जदी v वोल्ट हला पले एटी कोन हला पले एटी कोन हला 0 वोल्ट हला ता तो देखो भला चिंता करो एटी जदी v वोल्ट हला एटी कोन हो पले जदी v वोल्ट हला एटी कोन हो करंट सब कोन हायर पोटेंशियल रो लोअर पोटेंशियल को जिवो क्लियर हायर पोटेंशियल रो लोअर पोटेंशियल को जिवो ता तो एटी जदी v वोल्ट हला हम एज्यूम करबे एटी 0 वोल्ट क्लियर एटी कोन करबा 0 वोल्ट वाली एज्यूम करबा जेतबे ए करंट इज इटू कोन हला अगेन रिलीज होची जेतबे करंट ता देखो भला चिंता करो इट सपोज भाबो एटा 0 वोल्ट तो एटी जदी 0 आसिला एटी जदी v वोल्ट होइला अगेन एटी जदी v वोल्ट होइला एटी भी 0 वोल्ट लेगा भाबो भाबिलो क्लियर एटी 0 रहला एटी 0 रहला ताथ अगेन कोन होची करंट याड जाउची करंट कोन होची देखो याड गोटे करंट गला याड एटू ये कोन करची करंट सेंड करची ये भी करंट सेंड करची ताथ ये भी करंट सेंड करची भाइबो ताथ आमे जदी करंट जदी कोन जगह बाहरला ताथ 0 जदी हायर वोल्टेज बोली हम भाबिबा 0 जदी आमे एबे इमेजिन करिबा 0 जदी हायर वोल्टेज बोली भाबिबा कोडा लोअर वोल्टेज बोली भाबिबा -v वोल्ट को ताथ एटी कोन हला आ पाई ये कोन हेला -v वोल्ट हेला आ पाई ये -v वोल्ट हेला ताथ एमानंकर कोन हेला पोटेंशियल डिफरेंस कोन हेला सेम हेला तो हमें जानि छ जदी गोटे टर्मिनल रो एक्रॉस रो पोटेंशियल डिफरेंस जदी सेम ही जाए ताले ता देगी करंट जाई परिबो नाही देयर इज नो करंट व्हिच आर फ्लोइंग inside a particular terminal where the potential difference across the terminal remains same जदी potential difference जदी सेम ही जाए potential difference 80 v वोल्ट हेला 80 v वोल्ट हेला ताथ 80 0 वोल्ट हेला 80 0 वोल्ट हेला ताथ ए पाथ देकी करंट जाई परिबो नाही जदी आमे जदी आको धरि नबा 0 वोल्ट एज्यूम्ड एज हैला 0 वोल्ट एज्यूम्ड एज v वोल्ट सो across that point 0 वोल्ट across that point also v volt is here across that point 0 volt is here similarly across that point 0 volt is here that means across the path the potential becomes balanced that's why there is no current flowing through that circuit are you getting my point okay और आमे जदी भाबिबा एटा जदी v volt हुए तार एटा भी 0 volt ला तार एटा में 0 volt केन पाइबा तार आमे जदी एटा को 0 volt बोली भाबिबा ओके एटा को जदी 0 volt बोली भाबिबा तार एटा कोन हबो -v volt हबो ओके सिमिलरली आको जदी 0 वोल्ट भली भाबिबा एटा कोन हेतियो -v वोल्ट हबो ओके किंतु आमु कोन दरकार आउटपुट रे हम 0 वोल्ट बोली मेंशन करछे तारथ एटा जदी हम 0 वोल्ट भाबिबा तारथ ये कोन हेतियो अछि v वोल्ट हेतियो अछि ताले एमान पर डिफरेंस केते हेतियो v एटा 0 मिसले कोन हबो 0 वोल्ट हबो सिमिलरली एटा जदी v वोल्ट हबो एटा जदी 0 हबो एमान पर डिफरेंस आ पई कोन हबो 0 हबो तारथ हम v 0 पोटेंशियल डिफरेंस अक्रॉस द पॉइंट b आउ 0 पाई पाले किंबा तुम जदी डाउट लागुचे v जदी एटा हला एटा 0 वोल्ट नियो v जदी एटा हला आकु 0 वोल्ट नियो तो एटा जदी 0 वोल्ट हला ये कोन कला करंट सब कोन हबो हायर पोटेंशियल टू लोअर पोटेंशियल जदी जीवो तार तो 0 को जदी हम पॉजिटिव नेचर न पा लोअर पोटेंशियल के रहबो -v वोल्ट रहबो तार तो 0 एटी -v वोल्ट को लिख परिबा 0 एटी -v वोल्ट लिख परिबा तार तो करंट जाई परिबो तार तो आ टाइम भी जदी ये जो 0 वोल्ट हला ये -v वोल्ट दबो एटी ये जो 0 वोल्ट हला ये भी दबो -v वोल्ट तो जदी जे कोनोसी वे रे हम जदी रिप्रेजेंट करिबा तार तो ए पॉइंट ए जंक्शन आ ए जंक्शन रे कोन रहउची पोटेंशियल डिफरेंस हमरो सेम रहउची ओके ठीक बुझी परछो तार तो ए टर्मिनल देकी करंट पास हे परिबो नै तेनो हम ए टर्मिनल को उड़े दबा एलिमिनेट कर दबा नेग्लिजिबल लागबा एक टर्मिनल रहले केते न रहले केते किंतु ए जिंसु तमे कोडी पडिबो मु आगु कहबी किरचॉफ्स लॉ रे ए टर्म तमे यूज करिवो ए प्रकार सर्किट यूज होबो तो मु आगु गोटे कहि देली ए सर्किटटा मन रखो ओके तो मन रखो देयर इज ए पोटेंशियल डिफरेंस अक्रॉस द टू टर्मिनल remains same then there is no current which is flowing through that given parts or given terminal that's why that terminal becomes negligible okay so here that circuit represented as like that circuit clear आपको आमे ए सर्किट ही बिफोर सर्किट जेमी थिला से सर्किट ही रिप्रेजेंट कर दबा बुझि परछो मगथा जेमी थिला पूर्व सर्किट रे एबे हमें फाइंड कर परियो नै पले ए और बी एटा अछि आर एटा अछि आर एटा अछि आर एटा अछि कर दियो एबे कर दियो तार तो एदिटा कोन हला सीरीज हेला एदिटा कोन हेला सीरीज हेला Therefore here R prime equal to what? R plus R, R plus R, that is 2R. Similarly R double prime equal to what? That means what? R plus R, that is what? 2R. Therefore तो आमे कौन कर परिबा आको ए टाइप रे हम रिप्रेजेंट कर परिबा को टाइप रे देखो ए टाइप रे हम रिप्रेजेंट कर परिबा तथो ये कोन हेगिला ए माने कोन हेगिला ये दीटा जे मिसी गोटे हेगिला रजिस्टर ए माने भी दीटा जे मिसी कोन हेगिला गोटे रजिस्टर हेगिला ओके सो ये कोन हेगिला आर प्राइम हेगिला ये कोन हेगिला आर डबल प्राइम हेगिला आर प्राइम इक्वल केते अछि 2r अछि आर डबल प्राइम इक्वल्स 2r अछि तो ए माने कोन हेगिला बे पैरेलल कनेक्शन बोला देखा अछि तो हम पैरेलल कनेक्शन रा हम फॉर्मूला पुट करि परिबा देयरफॉर a और a क्रॉस b रो तथिबा रेजिस्टर रे इफेक्टिव रेजिस्टेंस केते अछि हम पाई परिबा देयरफॉर r effective can also be represented as 1 by r effective equal to what 1 by r prime plus 1 by r double prime. So 1 by r prime means what? 1 by 2r plus 1 by 2r. That means what? That is 2r is here, that is 1 plus 1 is here, that means 2 by 2r is here. Okay, so that implies r effective equal to what? Keta chhe r effective kya dasyo? That means 2 cancel out, that means r effective is r equal to here. So net effective resistance when they are connected in parallel is given by r, that is also r. Please note it. So r effective across a b equal to what? That is r. So this is the problem number 4. Okay. Now I am going to second problem, fifth number problem. Okay. Problem number 5th. Problem 5th. So here a point is here, b point is here. Okay. Here two resistors are there. They are connected to like that. R 2R R 2R R. Find effective resistance across AB. So here in the given circuit, please note it, listen carefully. If we assume that A and B terminal, they are connected to a potential difference or cell, so that A has higher potential, B has lower potential. That means there is a current which is passing through that circuit. I amount of current which is passing through the region A and which are leaving from that region B. Okay, so that is I. Okay, so here at that junction it becomes divided, that is I1, that is I2. Clear? Again that I1 also divided. Okay, that means what? That is I3. Okay, clear? And that is I4. Clear? Now I3 which is moving in that direction. Okay, that is I3 also. At that junction, that I4 again I3, they are moving, adding algebraically, that means I3 plus I4, which gives I2. So that gives as I1. Okay, that gives as I1, because I1 converted into I3 and I4. At that point they are also adding, so they represent I1 current. Now that I1 current, that is I1 current passing through that junction, again it meet into I2, so there is I current is here. So I current equal to I1 plus I2 is here. So I1 equal to what? I equal to what? I1 plus I2 is here. So at junction कौन I2 सहित तो कौन मिसला I1 मिसला तार तो कौन असला I1 plus I2 equal to I. So I current entering करथिला सर्किट को I current लीव करला सर्किट देखि तार था हम कौन करिबा देखो ए फर्स्ट टर्मिनल देखो फर्स्ट एंड को देखो एटी I3 कौन अछि एटी I3 अछि एटी I3 अछि एटी I3 अछि तार तो ए रीजन रे I3 कौन अछि सेम अछि current remains same. That means all resistors are connected in series. Here आको हम भागी दबा आको ग्रुप 1 दे दियो आको ग्रुप 2 दे दियो ओके आको ग्रुप 3 दे दियो here in group 1 okay here in group 1 the resistors are connected in series, so each resistors are connected in series, so that is R 2R, this one is R, that means R effective, that means R prime equal to what? R plus 2R plus R, that is equal to what? 4R. So that means R prime equal to what? 4R. Okay, R prime केते गेला बे 4 गेला. That means आपको अथरे ड्रॉ करो, डायग्राम को ड्रॉ करो. जदि हम डायग्राम को ड्रॉ करिबा तारथो ए कोन एक जो देखो अपन ड्रॉ करले कोन गेला देखो this one also this one okay, similarly this one okay, and that term, that whole things represent as a single circuit or single resistor, that is the effective resistance. So and this one represent as a R prime which is equal to 4R. But this one is, that is R is here, that is also 2R is here, that is also R is here, that is R is here, that is point A and that is B is here. Okay, here that is that circuit given as I3 and that circuit given as a I4. So I3 and I4 both have different currents are there. So as you know that in parallel collection what will happen, the current becomes distributed so that the each terminal current becomes different, so they are represented as a parallel connection. So in group 2 here in okay, in group 2 what will happen, two resistors, so this one is 2R and this one is R, so that is 4R and this one is R. Okay, so here R double prime equal to 1 by 4R plus 1 by R. So what will happen, 1 by R double prime equal to what? That means 4R is here. So that is what? 4R, that means what? 4 is here plus, sorry, this one is 1 is here. Okay, so if the LCM of 4R and R is given by 4R, now that 4R divided by 4R is given by 1, so we represent 1 is here. And this one is 4 is here, but that implies 5 by 4R is here. That means 1 by R double prime equal what? That implies R double prime equal what? 4R by 5. What? 4R by 5. So here again I represent that diagram. I'll represent that diagram in that way we can solve. So this is the resistor, that is R. Okay, and that is 2R, and that also what? That is 4R by 5 equal to R double prime, and they are connected in series. Clear? That is A and that is B is here. That is 2R. Now in that region what will happen, that 2R and R double prime both are in parallel connection because current becomes divided. Here in that direction I4 current is here I4 current is here. Clear? I4, and this one is I4. That is I4 and this one is I3. So I4 current and I3 currents are there. So they are represented as I1 current. Here I1 current is here. Okay. I4 plus I3 given as a I1 current, and that represent as I2 current. So current becomes divided, that I current divided into I1 plus I2. So if the current becomes divided, so that there behaves as a parallel connection. Clear? In parallel connection, what will happen? Here again, there becomes as a parallel connection. Behaves as a parallel connection. This one is 4R by 5, and this one is 2R. So 1 by R. Okay. This one is R triple prime. R triple prime equal to what? 1 by R double prime plus what? By R double prime 1 by 2R, which is equal to 1 by R double prime means 1 by 4R by 5 plus 1 by 2R. So here 5 is in numerator, so 5 by 4R plus 1 by 2R is here. Clear? That implies here if you get LCM, whose LCM is given by 4R. Now 4R becomes cancelled out, that is also 5 is here. 4R divided by 2R, that is given as 2. So that means 7 by 4R is here. 7 by 4R is here, that means 1 by R triple prime equal to here. That implies R triple prime equal to 4R by 7 is here. Here? That means R triple prime equal to कितना चला 4R. So here here we draw that circuit that is equal to R. Now that becomes as a what? That is equal to 4R by 7. R triple prime equal to 4R by 7. Sure? And that is also okay. That is also what? R. That is A and that is B. Okay. So here I current is here and that is also I current. That is also I current because I1 and I2 they are added. I1 and I2 they are added because they are connected in parallel. At that junction there becomes what? I current. So that they are connected in parallel. Sorry, they are connected in series because current remains same. So they are connected in series. So in series connection, what will happen? Net effective resistance R effective equal to, that means 4R by 7 means what? R triple prime equal to R plus R triple prime plus R. That implies R plus triple prime means what? 4R by 7 plus R is 0. So R effective equal to what? That means 7R plus 4R plus 7R divided by 7 equal to what? 7 7 14, 14 plus 4, that is 18R by 7. Therefore net effective R effective equal to what? 18R by 7. Answer 18R by 7. So this is the answer. Clear? This is the answer. So here you can say the net effective resistance R effective equal to what? 18R by 7. Okay, clear? So in that way we can solve all these problems. These are the easy problems. After that I'll discuss about lengthy problems which are related to series connection as well as parallel connection. Okay. Please note it. So this is all about resistance in series connection as well as resistance in parallel connection. After that, already I discussed about several problems which are related to series as well as parallel connection. If any doubt, then ask me. Please like and share my video. Okay. Thank you to all. Bye bye.